Hello everyone, my name is Amitesh Garg, and in this video, I am going to be presenting my Capstone project named Third Eye, a secure ambient environment. This project was made by a team of 4 that includes me, Arushi Vadva, Anmol Chabra, and Anukriti Garg, and was made under the supervision of Dr. Neeraj Kumar. In this project, we implemented an iris recognition system using image processing techniques as well as a real-time weapon detection system and integrated them all together using Raspberry Pi to create an overall secure ambient environment. So this is the whole prototype that we have built for this Capstone project, and as you can see that we have installed a door that will actually act for as an entrance to the room, and other than that these are all the components. And if we go inside, these are the rest of the components that have been displayed here. So now I'm going to explain all the connections that I've done for this Capstone project. We have used a Raspberry Pi model 4B with 4 GB of RAM. It has 4 USB ports. 2 of these USB ports have been used to connect the weapon detection camera as well as the iris recognition camera. One of this USB port has been used to connect the mouse to interface with the Raspberry Pi OS. And there are 2 wires coming from the back. One is used as a power input and the other is used as an HDMI port. Now there is an LCD connected here which is connected through 12 jumper cables that are going directly to the Raspberry Pi. There is this 4x4 keypad matrix used that is attached from under the box and is coming from out there and attached to the Raspberry Pi. There is a servo used that is getting attached directly to the Raspberry Pi. These are door sensors used. One of them is a magnet and the other of them is a sensor. The sensors wires are going directly to the breadboard, and from the breadboard there are 3 wires that are going to the Raspberry Pi. One is a VCC 3.3 volt that is connected through 10 k ohm resistor to the sensor. One is a GPIO pin and the other is ground. Other than that, as for inputs, we have used my iris for iris recognition system and the OTP. That the OTP is generated on the Raspberry Pi, displayed on the application connected to the Raspberry Pi, and is inputted through this 4x4 keypad matrix. So now I will show you the working of my Capstone project. So here is the code, and when I press run, you'll see that there are basically 2 options to open the door. One is press start to scan, that would invoke the iris recognition system, and the other is press D for OTP, that would invoke the OTP system. Right now, as you can see that the door is locked, you cannot open it. So if I press start, it will say starting scan in 3, 2 and 1, and it will start scanning. Right now I'll stop the code and I'll start it again as my iris data is been added into the iris recognition system. So what I'll do is I'll press my eye along the camera, and you'll see that it matches the iris recognition system and it opens the door. So I'll run it again. It has been run again, and now what we'll do is I'll press start to scan. So what you'll see is that the matching is successful and my door has been opened. So in this way, the iris recognition system successfully worked. So now what I will do is I will use another iris that has not been added to the database, and you'll see that the door which is currently locked will not open and it would show matching unsuccessful. So I'll do press start to scan, and you see that the iris is scanning, and now the iris is scanned and you'll see that it will show that match is unsuccessful. Yeah, so as you can see that as no match is found, you are unable to open the door, and if you are unable to open the door, that means that it is very secure and only the irises that have been added to the database can be used to open the door. Now it's time for the second part of opening our door, and that is through OTP. As you can see right now that the door is locked, and what I'll do is I'll press D for OTP. When I press D, it says enter OTP. Now I'll go to my app. This is the app interface. I'll press on generate OTP, and this is as you can see it's view. I'll view it. It says 2022, and what I'll do is I'll enter 2022, and now there are 2 options for me. If I press on input reset, then the door would not open and it would basically reset the input so that if in case you pressed a wrong key and you want to enter the OTP again, you can just enter it. So what I'll do is I'll press on C. So the input is resetted. So what I'll do it again, 2 0 2 2, and I'll press on accept. That goes for A. When I press A, you'll see that a door is open. Now, if I close this program and I start it again, right now the OTP was 2022, and what I'll do is I'll press D for OTP again, and I'll go for generate OTP. I'll click on view. 1 second. Yeah, so it says 1515. So now if I enter any OTP other than 1515, like I do 1 2 3 4, and I press accept, it goes for code rejected. That means it's saying the correct code is 1515 and the input is 1234. So the code is rejected. So it would not accept the OTP. So you can see that the through OTP our door is opened. Now you can see that the lock is showing the lock close. This lock close is due to the door sensors that have been installed here. And these door sensors are telling that the door is right now closed. It hasn't been opened till now. When I open this door, you'll see that it is showing lock open. That means the door has been opened and the two terminals of the door sensors have been separated. Now, once I bring these two terminals back together, you'll see that it says the lock closed. The lock has been closed, and you'll see that the door itself gets locked. This is basically the intrusion detection system, so that when a door gets opened and then you close it, it gets locked by itself, so that it does not remain open and another person cannot enter the door without using the iris recognition system or the OTP system. So after our door has been opened using the iris recognition system or using the basis of OTP, our weapon detection system will be activated. That would detect whether there is a gun or a knife in front of the camera using our weapon detection model that we have trained ourselves. So this is our weapon detection camera that is placed here, that has been connected to the Raspberry Pi, and we'll deploy the weapon detection model right now. Yeah, so as you can see, the camera has pointed on that wall, and right now it is showing nothing with an FPS of 3, approximately 3. So if I use this gun here and I place it in front of this camera, so you will see that it has started detecting that gun as a weapon. Yeah, you see, right? And if I stop using this gun and I even use this knife, this big knife, and I place it in front of the camera, you'll see that it will start detecting it as a weapon. Yeah, you can see right here. Yeah. Now, just for the sake of reference, if I use this small simple pen and I take it in front of the camera like this, so you will see that it is not able to detect this as a weapon. So that means this weapon detection system has been trained correctly and at very great accuracy. So this is a Capstone project that focuses on the growing ideas of smart and secure environments, providing a safe and dynamic smart lock and alert system for places. Thank you.